Hey, yo. You are his class go. Are you up for hangman, bro? If you want hangman, I'll give you one. No, I need to get I think it's gonna be something that you wear, right? Something that you wear. Is this? Bro, what's the C? Why? My letters are why. My letters are why.
So this and number 4 should be A3.
Okay. Now
A3.
Morgan, what you got for the first one?
1y to the 4th.
Say that again?
1 over y to the 4th.
All right, I didn't hear the word over the first time. Like that?
Yeah.
All right, correct. All right, Colin, next one.
4 over 5 or like x to the 5th.
Yeah, there's a difference between 5x and x to the 5th. All right, good. Josh, how about the third one?
A4 over 3B2.
Oh, daggone it. We were doing so good.
I got it right?
No, not yet. Zane.
I don't know.
You don't know?
I had.
That's what you had? Jordan.
Negative 3/8 to the 4th over 6.
Negative 3/8 to the 4th over what?
6a or 6 to the 7th.
It's a B. It's a B. I see what you're saying. Okay. Hey, negative numbers don't move. Negative numbers don't move. Only exponents. So negative 3/8 to the 4th. Number 4. Sam.
A3C4.
A to the 3rd power.
Yeah.
C to the, yeah, we're not droids. B to the 0, where'd it go? Okay, good. So that would be your answer, exactly like that. Christian, number 5.
I have no idea if I got this right, but Y3 over.
Oh, one second, sorry, malfunction. Y what?
Y3.
Y
to the 3rd.
Y to the 3rd.
And then over 3x to the 4th.
Okay, y cubed I agree with, x to the 4th I agree with. That 3, though, should stay in the numerator.
Oh.
That 3 is not to a power, so it is not to that negative 4th power. So it would be 3y to the 3rd over x to the 4th. Zach?
Oh, the last one.
Oh, no, I've got everybody gets a chance today.
Well, I don't know why, but I put ZY.
Evan, how about 6?
I don't know.
No. We're gonna know. Look, you guys, it's just like by following patterns. Do you have any negative exponents in here, Evan? Which one? First, what's the first negative exponent you see? Okay, so take that and move it down below. Make it b to the 5th. Does a squared have a negative exponent? So it stays right where it's at. So what should I do with the c to the negative first? Move it to the top. Becomes c to the 1st, which is just c. Do I touch the d to the 4th? No. There you go. A squared c, b to the 5th over d to the 4th. That's what you should have for that one. Okay, homework. We kind of did the first group. We're going to start with 16. Austin, what do you got for 16? 1 over x cubed. That is correct. Zachary, what do you got for 17? 1. Amanda, 18.
1 over t to the 9.
1 over t to the 9th. Jalen, 19.
3 over n2.
N squared. 3 over n squared, correct. Okay, Rachel. Oh, 20 is a hard one. Let me kind of just say, for 2/3 x to the -4th, that is the same. Because you got to, in the end, I want everything written with one numerator and one denominator. Okay, so you could, that's the same as 2x to the -4th over 3, because this x to the -4th is with the 2. You can think of it that way. And so all we got to do is move the x to the -4th. So it should be 2 over 3 x to the 4th. That's what that should be. Okay.
There's all kinds of different on that one.
Yeah, that's probably the hardest one of the group. And you don't, I don't want 2/3 and then times 1 over x to the 4th. I want it one fraction. All right, Morgan, what do you got for 21?
Negative. That's not right. Yeah.
What did you have? Maybe it's right.
-1 over 8 to the 2nd.
Like that?
Yeah.
Why is that the wrong answer?
I thought because it had a negative, it's not right.
You're allowed to have a negative number. You're right.
Oh.
This negative does not move. It stays with the 1. A to the -2nd goes down below. It's a squared. All right. Rachel, how about 22?
I had 10 x to the 4th over r to the 3rd.
Good. Brett, how about 23?
B to the 3rd, C to the 2nd over D to the 3rd.
Okay, check these. These are all right. Okay, these are good. London, how about 24?
5 over x to the 2nd, y to the 3rd.
Okay, good. Z to the 0 becomes a 1. Okay, we don't have the 5 stays. Make sure the 5 stays. This one is correct. X squared over y cubed. Very good. Jay Lee, how about 25?
I got s cubed over r to the 2nd, p to the 9th, and q to the 4th.
That is correct. The r squared is the only one that stays because it's a positive exponent. It stays in the denominator, and then everything else moves. Connor, how about 26?
I got A to the 1st or 1 or C to the 3rd over D to the 2nd or B to the 2nd D.
All right, one little thing you got wrong in there. That A to 0 becomes a what?
A 1.
A 1, so it's gone. I mean, technically, you can write a 1 there, but 1 times anything just leaves you C cubed. So we don't need to actually write it there. So that should be C cubed. And 27, Christiana. Put the J to the 5th up top. Okay, because J to the -5th's in the bottom, kick it up to the top. You can have 3 terms in the top, 1 in the bottom. Doesn't have to be like equal. Don't think it has to be. Just make sure everything's a positive exponent when we're done. G to the 3rd stays where it's at. K to the -1st moves up. J to the -5th moves up. H to the -2nd moves down, becomes H squared. And anytime you move it, it changes the sign. Okay, it changes the sign.
Are we taking off if they leave a 0 exponent?
Yes,
Okay. There was quite a few of that too.
yes. So for, which one has a 0 exponent? So like for 26, like if you left that as A to the 0, because you cannot have in your final answer a 0 exponent or a negative exponent. Okay, it needs to be simplified because it just equals a 1. And the same thing for 24, you should not have a Z to the 0 there. We're going to continue to hit this a little bit each day because like this is the first time you've done it, and it takes a couple of times, I think, just to really master it. A lot of you are better already. All right, but we want to make sure we can do them all without missing any of them for that. All right, we're going to move into 7-2. I got some guided notes here. think. Yep. Hey, the end of the 9 weeks is coming up Friday. We really have to take a look at where your grades are. I really don't know. And you need to take a look at where your grades are. You got 2 for them back there?
Yep.
Okay.
Hey, if you do not submit that worksheet, odds are you got a 0.
Hey, Austin showed me his. He said he had trouble submitting.
I got his.
Okay, all right. So that should be the only exception at this point. And Joe, like I said, Joe's got that guidance. Yeah. For that one, so I'm not sure about it. All right, scientific notation. Hanan, hadn't gotten to you yet. When I say the word scientific notation, you know what that is? You think so? Can you give me an example of it? Say that again? 10 to the third, you're on the right track, yes. Yeah, we're using exponents. Where do you use scientific notation at, or where is it? Have you used it before, I guess you should say. Significant figures, yes. It's used a ton in science. So it's used a ton in science. Because you want to talk about distance between planets, okay? It's very large distances. A lot of times it's easier to represent them as in scientific notation. You want to talk about where do we use what are some very small values that come up in science? So you want to talk about atoms and molecules and electrons, and you want to talk about how much they weigh or how far they travel. You use negative exponents. Okay, for those. This is the one case where you can have a negative exponent in an answers with scientific notation. All right, this isn't on your sheet yet, but just pay attention. We know 10 to the 0 power is 1. Okay. Basically, we want to figure out a shortcut for any 10 to a power. Well, 10 to the 0 is 1, 10 to the first is 10, 10 squared. If you're going to the left, you're multiplying by 10. If you're going to the right, you're dividing by 10. It's really based upon the number 1. So starting at 10 to the 0, 10 to the 0 is 1, 10 to the first is 10, and then 10 to the negative first is 0.1. So basically start at 1, and this number here, this exponent, tells you to move your decimal point left or right, and then it tells you how far. So if you think about 10 to the 4th, start with the number 1. Think about it as 1.0, and if it's a 4, we move it how many places to the right? You're going to move it 4 places to the right. So 1, 2, 3, 4. And so in the end, 10 to the 4th, okay, is the same as 10,000. 10 to the negative 6, start with the number 1 point and then move it left 1, 2, 3, 4, 5, 6. Okay? And it becomes 1, 2, 3, 4, 5. So you move it 6. Now, you got to watch. If it's a positive number, you're going to add that many zeros. If it's a negative exponent, you're actually going to add 1 less. So if it's 10 to the negative 6, you're actually going to add 5 zeros. But the key is you start with the number 1 and you move left or right off of the number 1. So when I say the number 1, 1.0. 1.0. Okay. So what do you think about 10 to the negative 2nd? Start with the number 1 and we move it how many to the left? You move it 2 to the left. So think about that. I go 1, 2, Hold on. I screwed that up. So when I move it 1, it puts it in front of there. So I get 0.01, and you don't need to write that second 0, 0.01. 10 to the 5th, start with the number 1. Okay, point, and then you move it 1, 2, 3, 4, 5, and I put in a 0 in each of those spots. So I get 1, 2, 3, 4, 5. That is 100,000. 100,000. I think that was our bonus this year, Mr. Schiller. Got $100,000.
Ballpark.
Now, shortcut, if it's a positive exponent, add that many zeros. If it's a negative exponent, add 1 less in. So 10 to the 10th, start with 1, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that's a big number. Is it 10 trillion or 10 billion? 10 billion. Too many zeros for me. 10 billion. Okay. That's just for a power of 10. Now go the opposite way. Go the opposite way. All right, what do you think 1 million is as 10 to a power? Okay, Christiana. 10 to the 6. It would be. All you gotta do is this, there's a decimal point. How do I get back to 1? I go 3, 4, 5, 6. 10 to the 6. Colin?
The next one is 10 to the negative 4.
10 to the negative 4th, because you go 1, 2, 3, 4. You got to get back to 1. So it actually has to get in front of the 1. 10 to the negative 4th. And 1,000.
10 to the 3rd.
10 to the 3rd. Yep. 10 to the 3rd. All right, good. 10 to the 6th, 10 to the negative 4th, 10 to the 5th. So that's just 10 to a power. Zach? You got I don't even know what the next one is. All right, wait a second here for the next one. This is not on your guided notes, but just pay attention. So like somebody says the distance between these two planets is 23.89 times 10 to the 8 miles. Like, and you want to write that out. If what you do for this, whatever this is, take your decimal point, move it 8 to the right. Okay, whatever's on that power. So it's the same thing as multiplying it times 10 to the 8. So that ends up being 2,389,000,000. If it's a negative, that's just the number 467. Start where the decimal point would be, move it 3 to the left. So on that next one, I'm assuming this is the next one, right, Zach? Is that the next one on our page? All right, what do I get for that one?
It would be 85,340,000.
85,340,000. So that means you started where the point is and you moved it 1, 2, 3, 4, 5. Yep. So don't start at the beginning. Start wherever the decimal point is. And if it's a positive 5, move it 5 to the right. If it's a negative 5, move it 5 to the left. So that's right here. Does that make sense? Oh, no, not right. No. No. All right, the second one, 0.163, 10 to the negative 2nd. Which direction do I move the decimal point, Sam?
Right.
Not right, left. So then what's my answer going to be?
Oh, it's gonna be 0.00163.
Good. 0.00163. Now, a lot of you will put a 0 in front of here, which is fine. I don't get too concerned about that. If you just put 0.00163, that'd be fine. Okay, on that. All right, so that's writing it. And so we talked about standard form versus scientific notation. Scientific notation. Okay, and it does have a little bit of a definition that you got to watch. Because not everything, even though you think it is, may not be in scientific notation. 2 key things. This number right here has to be between 1 and 10 to be considered in scientific notation. So 3.5 is fine, 9.98 is fine. And then the second part is a power of 10. So 3.5 times 10 to the 11th. That's going to be a big number. 9.98 times 10 to the negative second. It's going to be a smaller number. Not too small, but that's going to be a small. So that's the keys to scientific notation. All right, are we on the bottom there? Flip it over to the back, if you would. Okay. 145,000. 145,000. Any idea what that would be in scientific notation? I just want you to take it at a step. Christian, what do you think?
10 to the third.
Just 10 to the third?
Oh, wait. 145 times 10 to the third.
Okay, don't write this down yet because I'm going to tell you that would not qualify for scientific notation because that 145 needs to be between 1 and 10 to be the final answer. Amanda?
1.45 times 10 to the 10,000.
There you go. See what you got to do for this. Start where your decimal point is and move it till you have a number between 1 and 10. So you got to go all the way back to right in after the 1. Make it 1.45. Don't make it 14.5. Don't make it 145. So this is officially in scientific notation because this number here is between 1 and 10. Okay, so you got to take it to that point here. Now, where do I need to move my decimal to? Well, between what two numbers, Connor?
What do you mean by like between the two numbers?
What two?
The next question. Between the 3 and the 2.
All right, you need to move it. Yep, correct. You need to move it between the 3 and the 2. And so 1, 2, 3, 4, 5 spots. So Connor, what would be my answer there?
3.24 times 10 to the negative 5th.
3.24 times 10 to the negative 5th. Yep, if you go from a small number like a decimal, that's where you got to make it a negative. If you move it to the right, you make it a negative. If you move it to the left, it's a positive. All right, now this next one, you say, hey, that looks like it's in scientific notation, but Preston, why isn't it?
Because it's not between 1 and 10.
It's not between 1 and 10. Do you know what the answer would be? You got an idea?
Would you just multiply it? Or would you just add 6 zeros?
No. You're going to, well, you got to keep it. It's got to look like this when we're done. Okay? Colin?
2.45 times 10 to the 8th.
All right. So he says 2.45 times 10 to the 8th. Let's take a look. Here's the decimal point, though it's not written. We got to move it 1, 2, which means I got to change this by a 2. It's either going to go up or down. Here's the deal. If this number goes down, then this number has to go up. Okay? So we went down by like 2 place values. That has to go up by 2 place values. So if I had 387 times 10 to the negative 4th, now be careful here, it would be 3.87. That went down. What would actually make that one go up? Okay, it's a negative. Is that?
It would be a negative 2.
It'd be negative 2 because actually negative 2 is bigger than negative 4. So you just got to be careful there. But that would be the case. So you got numbers that look like they're in scientific notation, but they're not. All right, think about this one. 0.56 times 10 to the negative 5th. 0.56. All right, Colin?
5.6 times 10 to the negative 4th.
5.6. So you made it bigger, right? So we got to make this one smaller. What's smaller than negative 5? Not negative 4. Negative 6. Okay? Negative 6. So you make one bigger, make the other smaller. You make the other one smaller, make the other one bigger. Okay, vice versa. So you just got to be careful here because these look like they're in scientific notation, but they don't qualify because you got to have that first number between 1 and 10, and it can't equal 10, less than 10. Okay, bigger than 1. All right, now, where do we go? All right, it says write the following numbers in standard form. That means basically no exponents. So you got number 1 there. 4.62 times 10 to the 9th. Basically, you take it and you move the decimal point how many spots to the right? 9. 9 spots to the right. Whoa, what's that gonna be? 4. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? Yep. 6.14, I'm gonna move it 6 places to the left. So I start there, so when I move it, 1, 2, so I gotta add, I think, 1, 2, 3, 4, 5, 6, 1, 4. 1, 2, 3, 4, 5, 6. Does that look right? Should have actually how many zeros in front of there? 5 of them. Anybody know how to say that number? Like the real number? I don't even know if I know how to. What's the first one? Tens? Hundreds? Thousands? 10,000s? 100,000s? Millions? 10 millions? What do you got?
614, 10 millions, or 100 millions.
I think that's right. Is that right? 614, 100 million. Okay. All right, and this third one. 12. Write that in standard form. It is in standard form. Nothing you can do. So don't let me fool you. Done. Done. Oops. With an E. Got it? All right, that last one there. Order the list of numbers from least to greatest. All right, you try it. I want to just see what your instincts are. What are those from least to greatest? Smallest to biggest. Smallest to biggest. Yes. All right.
So also how much work we made for that?
Well, I forgot to
Because
I thought we had you submitting this stuff.
Right.
it wouldn't submit, like I took the picture, but when you drove from
We did that.
the, I don't know what.
Oh, where's my grade book? Oh, I see.
We don't have any more summary assessments.
Oh, I got it. All right. What do you got, Evan? What are we starting with?
5.4 times 10 to the third negative.
Okay, and then what's the next one?
1.3 times 10 to the negative second.
1.3 times 10 to the negative second. And then what will be the next one?
1 times 10 to the negative second.
All right, let's stop right there. Make sure we're good. I agree. Or wait, hold on. Take a look. Here's a big question. 10 to the both have 10 to the negative second, right? Which one's smaller? Look at the number in front. Go with whichever number is smaller. So what's smaller, 1.3 or 1? 1. Go with that. Okay. So this would actually be 1.3 times 10 to the negative second. We would move it 1. We would move it 2. It would be 0.013. And this is 1 times 10 to the negative second. That would be 0.01. And you can put a 0 on there if you want to. So this would be 13 thousandths. This would be 10 thousandths. So look, if these are the same, go to the number. So make that a 1. make that a 1 and make that a 1.3. Okay, so that 5.4 times 10 to the 3rd is clearly the smallest. So that took care of that one, that one, that one. The next one should be 10 to the what? Okay, Christian?
10 to the third.
6.3 times 10 to the 3rd. And what do you think the order is for the last two?
2.1 times 10 to the 6.
Okay.
4.1 times 10 to the 6.
Good. Yep. If you got the same exponent, go to the constant and just say, all right, which one's smaller? Which one's bigger? Do it that way for this one. All right, now this is the only case where we are allowed to have a negative exponent. We are allowed to have a negative exponent because we're in scientific notation. All right, so page 455, 16 through 27, odd, 30 through 43 all.